Yeah. Grouping of resistors.
Yes, sir.
Yeah. So first we will discuss about series grouping. Series grouping of resistors. So here we write three resistors,
Yes,
and
sir.
then connected to a battery. This is positive, this is negative. So this resistance is R1, this resistance is R2, this resistance is R3. Yeah. So here this is V1, V2, and
With
V3,
three. Yes,
and this is V. Okay. Now the potential drop, see, one after the other. If you connect a resistor one after the other like this, then
yes,
the uh, we call them as connected in
series.
series.
Yes, sir.
Okay. Now, see here, when you have connected resistance in series, then
Yes, sir.
the current flowing through all of them will be same.
Same.
So
Yes,
how
sir.
many resistors you have connected in series, all of them will have same
Same
current.
current flow. Yes, sir.
Okay, so imagine this, because there is only one path, right?
Yes, sir.
So current can pass only through this way,
Yes, sir.
right? So same current will flow. So now here you can write V is equal to I
I
into
have.
R1.
Yes,
Okay.
sir.
So similarly, V2 is equal to I into R2,
R2.
and V3 is equal to I into R3.
R3. Yes, sir.
So now here you can write V1 is 2, V2 is 2, V3
Yes, sir.
is equal to R1 is 2, R2
R2
is
is
2,
R3.
R3.
Yes, sir.
Okay, because the current
Current is
is same.
same. Yes, sir.
Okay. Uh, Power P is equal to I square R. Power
Yes,
P is equal to I square R, because power P is equal to V into I.
yes, sir.
V is equal to IR into
Yeah.
I.
Yes,
So
sir.
it will become P is equal to I square R.
R. Yes,
So
sir.
here power P1 is 2, P2 is 2, P3
P3.
is equal to, now I is same, so it is R1 is 2, R2 is
R2 is
2,
R3.
R3.
Yes, sir.
Okay. Now here we can write V equivalent, sorry, the supplier V is equal to potential drop at first resistance plus potential drop at second resistance plus potential drop at third resistance. V
Third
is
is
equal to V1 plus V2 plus V3.
V3.
So
Yes,
V
sir.
is equal to I into R equivalent, that is equal to IR1 plus IR2
IR2 plus
plus IR3.
IR3. Yes, sir.
Then R equivalent is equal to
R1 plus
R1
R2 R3.
plus R3. So R equivalent is equal to sum of the resistances.
Yes, sir.
Okay, now that's fine. Now here, if you want only if two resistors are there, then R equivalent is equal to R1 plus R2, if only two
R2.
are there.
Yes, sir.
Okay.
Yes, sir.
Now, potential difference across any resistance. Say for example, if you want V1 is equal to this one I will pick V1 is equal to I into R1.
R1.
But
Yes, sir.
what is I? I is equal to Ohm's law. V is equal to IR.
IR. Yes,
I
sir.
is equal to V by
Yes.
R
R.
equivalent. Okay,
Yes.
here total. So I is equal to V by R
Equivalent.
equivalent into R1.
R1. Yes, sir.
So V1. So we can write V1 is equal to V, that means the battery voltage, into R1 by
R1.
R
R
equivalent.
equivalent. Yes, sir.
Okay, if 2 are there, R equivalent will become R1 plus R2. If 3 are
R2.
there, then it will become R1 plus R2 plus R3.
R3. Yes, sir.
Okay, similarly, we can write the values of V2 and V3 also. V2 will become V into R2 by R equivalent. V3 will become V into
V
R3 by R equivalent.
R equivalent. Yes, sir.
Okay, right. Now, so this is a series. Now, if n identical resistors are connected,
Yes, sir.
n identical resistors are connected, n identical
Resistor.
resistors are connected, then the R equivalent is equal to NR.
NR. Yes, sir.
R equivalent is equal to NR. Then potential difference, because now if they are equivalent, then potential drop will be same, and
Same.
that V is
Yes,
equal to, that V dash is equal to V by R,
R.
V by N, sorry, V by N, V by N.
N. Yes, sir.
So this is a series,
Yes.
grouping of resistors in series. So now we will discuss grouping of resistors in parallel. Let us take the resistors in parallel.
Yes, sir.
V. Now, when resistors are in parallel, let us take
Yes,
this
sir.
resistance is R1, this resistance is R2, this
R.
resistance is
R.
R3, and this current is I1.
I1.
Current is I2, and here the current is I3,
I.
and this is I.
I. Yes,
Now
sir.
we see that when you connect the resistors in parallel, the potential difference is same.
Same.
Potential
Yes, sir.
difference is same.
Yes, sir.
Potential difference is same. Across the resistors, V is same because they all have same
Same
potential
potential.
difference across them. V is same when you have connected them in series.
Yes, sir.
Yeah, sorry, when you have
Parallel.
connected them in parallel.
Parallel.
Now
Yes,
you
sir.
see here, now there are many pathways. The current can either travel in this way or this way or this way.
Yes, sir.
So more current will flow when where the resistance is less.
Yes,
Okay,
sir.
more current will flow when the resistance is less. Okay, V is equal to IR. I is equal to V by
V
R.
by R. Yes, sir.
Now we know that this V is constant for
Yes,
parallel.
sir.
So we write I is inversely proportional to R. So if less current is there, if more resistance is
More
there,
resistance.
then in that
Current.
less. less current.
Yes, sir.
Okay.
Yes, sir.
And power, when you write power P is equal to
I square R.
V into I. I is equal to V by R. So
Yes,
that is equal to V square by
R.
R. So now
Yes,
here this is V is constant. So P is inversely proportional to
R.
R.
Yes, sir.
So I will write here P1 is to P1 is to P2 is to P3.
Yes,
Power, the ratio of powers is in the inverse ratio of the resistance. Okay.
yes, sir.
The power consumed is in the inverse ratio of their resistances.
Yes, sir.
Now, 1 by, so now here I will write the current I is equal to I1 plus I2 plus I3.
Yes, sir. I two.
I is equal to V by
V
R, that
I
is
two.
equal to V by R1 plus V by R2 plus V by
V by R
R3.
three.
Now, if I take this V common and if I cancel, then R equivalent is equal to 1 by R1 plus 1 by R2
Two
plus
plus
1 by
one by
R3.
R three. Yes, sir. Yes, sir.
This R equivalent can be written as R1, R2, R3 by R1, R2 plus R2,
R two
R3
R two.
plus R3, R1.
R one. Yes, sir.
When two resistors, only two are there, only when two resistors are there, then R is
R
equal
one
to
R two. R two by
by
R one plus R
R1
two.
plus R2.
R two. Yes, sir.
Now, now here, if I ask to calculate, now what is the current in I1
Yes,
or what is the current in I2? Now, if only two resistors are there, then I will draw like this. Two resistors I will consider.
yes.
This current is I. Here it is I1. Here it is I2.
I two.
And the resistances are R1 and
R two.
R2.
Yes, sir.
Then I will write I1 is equal to I1 is equal to I1 is equal to resistance in the opposite branch. So current I into resistance in the opposite branch R2 by
R
total
one
resistance R1 plus
one plus R two.
R2.
Yes, sir.
Similarly, I2 is
I two
equal
is
to
equal to
I
I in
into
R one by R one plus R two. Yes, sir.
R1 plus R2.
Yes, sir.
So we calculate I1 and I2.
I yes, sir.
If n resistors are connected in parallel, n resistors are connected in parallel, then R equivalent is equal to R by n,
I
equal,
N. Yes, sir. Yes, sir.
equal. This is when they were equal.
Equal. Yes, sir.
Okay. In series, if one of them is broken, the circuit is broken, nothing
Yes,
will glow.
yes,
In
sir.
parallel, if one of them is not
Blue.
working, then also it is okay because the current will flow through these two. Okay, so in this decoration lighting festivals,
Yes, sir.
okay, where they use
Parallel
if you use series combination, then if one of them is not, if none of them is not working, then remaining doesn't work.
work. Yes, sir.
Okay. Household appliances basically are connected in parallel.
Parallel. Yes, sir.
Okay. Right. This is series grouping and parallel grouping.
Parallel. Yes, sir.
Okay.
Yes, sir.
Now, equivalent resistance of infinite network of resistance, infinite ladder. This is
Yes, sir.
important model. Infinite ladder, infinite ladder.
Yes,
So
sir.
you have this is R1, this is R2.
Yes, sir.
So infinitely it will go on like this. So again you will have R1,
R2. Yes, sir.
R2,
Yes, sir.
R1, and that is R2. So it goes on like that, infinite series. Then the shortcut method is, so this is A and this is B. The
B.
shortcut method is R resistance between AB is equal to half into R1 1 plus root of 1 plus
Yes, sir.
4 into R2 by R1.
Mm.
That's infinite ladder.
Yes, sir.
Okay.
Yes, sir.
Now, next one is Wheatstone bridge, balanced Wheatstone bridge condition.
Yes, sir.
Wheatstone bridge balanced. Balanced Wheatstone bridge. Now, if these the resistors are like this, say this is A,
A, B.
B, C, and this is D, and you got a galvanometer here
Yes,
between these
yes,
two.
sir.
Okay,
Yes, sir.
so let us take this as P, this as Q, this as R, and this
Mm.
as S.
Yes,
If P by Q is equal to R by
R by.
S,
Yes, yes, sir.
then we say the bridge is balanced.
Yes, sir.
Okay, if P by Q is equal to R by S, then we say the bridge
Bridging
is balanced. Okay, then no current flows. No
yes, sir.
current flows through this
Oh,
galvanometer. Okay, then what we do, they then just we consider it like P Q, and here
uh,
R and S.
S. S.
So we solve problem like this: P Q R and S. So
Series.
these two are in series.
The
So that is P plus Q,
Q.
and these two are in
Series.
series.
R plus S.
So R plus S,
S.
and P plus Q and R plus S. Say, let us take
Are in parallel.
yeah, let us take this as X, this as Y.
Yes, sir.
That is R plus S. Then we will write the effective resistance is equal to R effective is equal to
X into
XY
Y plus
by XY by X
plus Y.
plus Y.
Yes, sir.
That is P plus Q plus
Into
R plus S
uh,
by into no,
into.
yeah,
Yes, sir.
into by X plus Y, P plus Q
P plus
plus
Q plus R plus S. Yes,
R
sir.
plus S. That's how
Yes,
we calculate.
yes, sir.
Okay.
Yes, sir.
All right. Now this is balanced.
Yes, sir.
Sometimes unbalanced. How to solve the unbalanced Wheatstone bridge? We can use by using the loop law. By using loop law also we can solve this problem, but we will go with the shortcut.
Yes, sir.
So this is P, that is O, and this is O, and this is P. Okay, so
Yes,
you will be given 2 ohm, 3 ohm, and 3 ohm and 2 ohm.
yes, sir.
Okay, now here P by Q is not equal to R by S. So this current is the potential difference across these two was different. So we
Yes,
cannot
sir.
remove this resistor. So
Yes, sir.
the shortcut formula is the resistance between A and B. Let us take this terminal as A and this terminal as B, and RAB is equal to 2PQ.
PQ.
PQ, QP.
Yes, sir.
Okay.
Yes, sir.
2PQ plus G into P plus Q
Yes, sir.
by 2G plus P plus Q. So this is the formula which we use to
Unbalanced.
calculate
Unbalanced with two.
the unbalanced
Yes,
Wheatstone bridge.
yes, sir.
Okay, right. So it's a problem here. Solve one problem. So if a problem is given like this, say this is 10 ohm, 10 ohm, 20 ohm, and 10 ohm,
Yes, sir.
and this is X. From here to here it is 10 ohm.
Yes, sir.
From here to this point is Y.
Yes, sir.
Now here what we do is So this point is connected to here. So this is also X.
Yes,
So
sir.
let us take this as A, and here this point as B.
Yes, sir.
So I will draw this. This is X, this is Y. So from X to A from here, X to
Yes,
A.
sir.
So this is A, X to A. One
One.
resistor is there.
Yes, sir.
Then X
X
to
to
B,
B. One resistor.
one resistor is there. So
Yes,
X to A is 10 ohms. This is also 10 ohms.
yes, sir.
And A to B is 20 ohms.
20 ohm.
Then B to Y is 10 ohm.
10 ohms. A to Y.
Then
A to Y.
A to Y is 10 ohm. A to Y is 10 ohm. Okay.
Yes, sir.
A to Y is 10 ohm.
10 ohms.
So clearly you can see P by Q is equal to R
R
by
by S.
S. So you
Yes, sir.
remove this resistance and
Yes,
then
sir.
you calculate, you solve the problem. These two are in series. So this
It is
is 20 ohm
20
and these two are in series.
series. 20 into
So that
20
is
by 20
20 ohm and these two are parallel.
parallel. Yes, sir.
These two are parallel means 20 into 20
Into 20
by
by 20 plus 20.
20.
Yes, sir.
That is 400
100
by
by 40.
10.
10. 10 ohms. Yes, sir. Yes, sir.
Now this is A, this is B,
Yes, sir.
and I'm going to write the resistances here. Here this is R. Okay, each resistance is R.
Yes, sir.
Each resistance is R. So then now actually what we do, I will bring it here. Okay, I will bring this one here. I will just hold this one and I will bring it here. If I bring it here, then it will be like this from A. Now let us name the point. Say let us call this as C. This is D, and then this is say E.
Yes, sir.
So now here from A to C. So let us take C here and D
C.
here and E here and just write A to D. A to D, one resistor is there, and A to C, one resistor is there. A to C. Then C to D, one resistor is there. C to D, one resistor is. And then D to E, one resistor is there. One resistor, D to E. And then C to E, one resistor is there. So here all of them are equal resistances. So P by Q is equal to R by S. So I can remove this resistance.
Yes,
So
sir.
what I'll get is 2. This is R plus R is 2R and R plus R is 2R. Now these two are in parallel. So what I can do is write R1 R2 by R1 plus R2,
2R plus 2R. Yes, sir.
because R equivalent formula is R1
R1
R2
out,
by
R
R1 plus
R2.
R2, that is equal to 4R square by 4R, that is equal to 4 and 4 gets cancelled. You get R.
R.
Okay. So if each of them is having resistance 2 ohm, then the answer will be 2 ohm. Okay. This is CBSE 1990, CBSE PMT. Okay. 1995. So what you call NEET earlier.
Yes, sir.
Okay. Is R. No, there he gave each resistance is 2 ohm. So the answer will be 2 ohm. Here I took R. So I got R.
R. Yes, sir.
Okay. All right. So again, you will have a lot of problems based on Wheatstone bridge.
Yes,
Okay,
sir.
and further equivalent resistance in the circuit. One model I will tell you. Uh, Another model is A2C
Yes,
and C2B, and then here you have a to this
yes, sir.
point, and then from here and from here to here. Okay,
Yes,
and from here you have one resistor, and here you will have another resistor. Now if you see here, then you cannot write like resistance in series and parallel. Let us write each resistance is R. Now you cannot write here series and parallel. Okay, so what you have to do is, now here this will have this is like a mirror image. Say for example, if you just fold it into half, then
yes,
it looks exactly same. Okay,
yes,
so we have to remove that connection.
yes, sir.
So if you remove that connection, it will be like this. Now I removed the connection, okay, and moved it up.
Yes, sir.
Okay, now we can calculate the problem. The problem is easier now. So here this is R, this is R, this is R. So R and R is 2R.
Series.
This is in series, so this is 2R and R, and this is R, this is R, and this is R. So
Yes,
now here it is R plus. Now here this 2R and R are in
parallel.
parallel,
Yes, sir.
plus R, and that is in parallel with R plus R,
R
2R.
plus R, 2R. Yes, sir.
So how much you will get here? This is 2R. This is if you calculate parallel between
Yes,
R and 2R, the resultant will be 2R square by 3R. That is equal to 2R by 3.
3. Yes, sir.
So this is 2R plus, this is R,
Yes, sir.
R, 2R plus
2R by 3.
2R by 3 by 2R. That is equal to 3 2s are 6R plus 2R by
6R
3
by 3
by
by
2R.
2R.
That is equal to
8R by 8R by
8R by 6R.
3. Yes, sir. Yes, sir. R by
So
3.
that is
4 by 3.
no, oh, 4.
4 by 3.
No. This and this are in parallel. Na? R1, R2, right? R1, R2. You have to do R1, R2.
Series. No,
Yeah.
sir. 2R plus 2R by 3.
2R plus 2. Yeah, 2R plus
2R
2R
by
by
3.
3 is in series, right? So
Yes,
this
sir.
is 6R plus 2R by
6 R
3.
2 R by 3. Yes, sir.
That is 8R by 3, right?
3. Yes, sir.
Now this is 8R by 3 and
2 R.
2R are in
And in parallel.
parallel, right?
Yes, sir.
So this is 8R by 3 into 2R
Yes, sir.
by 8R by 3 plus
2 R.
2R, that is equal to 8 to the 16
16
R
R
square
square
by
by
3
3.
by
That
8R plus 6R by 3.
3.
So
3
this
3 get cancelled.
cancel, that is 16R square by 8R plus 6R, 14R
14 R square.
square
Okay.
2, 16,
8 by
8R
R
by
7.
7.
Yes, sir.